Hi everyone and welcome to this video on the remainder and factor theorem, part of, well actually I'm going to say the year 10 course, but yeah, year 11, year 12 and all over the place, and really builds on the work we've been doing in quadratics. My name's Darren from Maffs Guru. I say it really slowly because I've got some great software that's using AI before it takes over the world and destroys us all to do my little subtitles for me. It's very exciting. But Maths Guru or Maffs Guru, it gets very confused about. Anyway, enough about that rubbish. Right, Maffs Guru is my little corner of the internet where you can download the lesson notes, watch the videos, all in sequence. What else can you do? There's exam questions and all so much more. It's free to sign up and hopefully it's there provided as a resource for you to use and smash mathematics in an interesting way, because hopefully my videos are unique and interesting and will help you do very, very well. Right, enough of that for the moment. What are we doing? Learning objectives, always ask you to have a read over these. I'll review them at the end to make sure that we've actually covered everything. I'd hate to forget anything, but generally speaking, I will always do more than I can here. Right, let's look at our past learning. What on earth did we do in previous videos? You're saying, huh? Previous videos? Where can I watch those? Hey guys, I've already told you, Maths Guru, and also YouTube. And you're going to say, YouTube? I have a YouTube account, which yesterday lost 25 subscribers. Why? Not because my content is bad. Well, at least I hope not. I haven't really thought about that one. It's just because people go, oh yeah, I don't want to watch maths videos anymore. And then I lose a load of subscribers. I'm the only channel going backwards. Now, if you subscribe, it just tells me that you've watched and that actually you're supporting what I'm doing. It's great if you can. Otherwise, I'm sitting here talking to myself. Even the dog's given up. Right, so here's the past learning. In the past video, we showed you, or I showed you, how to do polynomial division. Why? Because it becomes really, really important, particularly in this video. And we talked about quotients, divisors, the dividend, and remainder. And in fact, that remainder becomes critically important because when I did long division in the previous video, we found out that actually we had a remainder, and we went back to, you know, primary school and we would have written something silly like 277 remainder 1. Now, because it had a remainder, it meant it didn't divide in a whole number of times. But what happens if a number divides in a whole number of times? If I asked you for the number 12 to find the factors of 12, what would you tell me? 1, 2, 3, 4, 6, and 12. Why those numbers? Because they divide in a whole number of times. Or more importantly, they don't have a remainder. So a factor is a number that divides in with no remainder. So would it be useful, you think, in maths for that to be 0? 100%. And that's really what we're going to be dealing with in this video here. So the idea of factors and factorizing. Where have we met factorizing before? Quadratics. And when you factorize a quadratic, what did you end up doing? You had the null factor law, yada, 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 yada. But again, I don't want to rush things. So in the past video, as I said, we did long division. Can actually help us to know if something is a factor or not, right? So the first thing we're going to do is whether something's a factor. How do we do that? It'll have no remainder, i.e. the remainder would be 0 after we do long division. If you haven't watched the video on long division, as I say, it's on YouTube or Maths Guru for you to be able to watch. Here we go. So what I'm now going to do is I'm going to do x cubed, he says every single time, x cubed minus x squared plus 2x minus 3, and I'm going to divide that by x minus 2. Okay, right, so the rule is take the first term here and divide it by the x. X cubed divided by x gives me x squared. As soon as I've written something on the top, I multiply that by everything in front and write it down. So x squared times x gives me x cubed. X squared times minus 2 gives me minus 2x squared. Align and subtract them. Right, so x cubed minus x cubed, they disappear. And then I've got minus x squared minus 2x squared, which becomes plus 2x squared. So that's just going to give me x squared. I've done the subtraction. What do I do now? Drag down. So that plus 2x becomes there. And I start the process again. But this time I say how many x's go into x squared. So x squared divided by x gives me plus x. I've written something on top. So I do the plus x times everything there. So that gives me x squared. X plus x times x gives me x squared. Plus x times minus 2 gives me minus 2x. Subtract. X squared minus x squared, they go, which is good. plus 2x minus minus 2x would be plus 2x. So that's going to give me 4x. And then bring down the minus 3. And we start again. Why do we start again? Well, because that's the rules. So x into 4x goes plus 4 times. I've written something on the top, so we now multiply the plus 4 by the x minus 2. 4x minus 8. Ka-ching. Take them away. 4x minus 4x goes minus 3 minus minus 8 becomes minus 3 plus 8, which gives me 5. And I can now tell you that x minus 2 is not a factor of this. It does not divide in a whole number of times. Why? Because I have a remainder. I have a remainder of 5. Okay, so now what do I do with it? Well, just for fun, before we go into any more of the learning, I just want to see what P2 would be. And you're going to say, what's P2? Again, I've got another video on this. It's about polynomials. All right, but P2 means now, where we see P of x, I now want P2. And what do you notice? I've replaced the x with a 2 here. And what I do on the left-hand side, I must do on the right-hand side. So let's just do that here. So that's going to be 2 cubed minus 2 squared plus 2 times 2 minus 3. Now again, if you notice what I've done there with the dot, it's a very British thing. We do a multiplication sign down on the bottom, all right? It's not a decimal point. It's not 2.2, it's 2 times 2. Right, so let's see what we've come up with there. So 2 cubed is 2, 4, 8. 2 squared is 4. Plus 2 squared is, 2 times 2 is 4. Minus 3. Well, that plus 4 and a minus 4 go. 8 minus 3 happens to be 5. That's interesting. Those seem to be the same. Is there a reason why? Come to that in just a moment. Right, let's go back to our remainder theorem.